I want to create a procedural planet generation system to create a range of geometry and textures to populate space in my new Java game. So I first started with a sphere model generator. This is fairly simple, it's just a little bit of maths, so I'll leave a link in the description to an article that shows you how to do it. Well, shows you the maths, but you can see here that I've also unwrapped it with text coordinates, so the X just increases around the sphere and the Y increases downwards. You can see there's also a seam, but you won't be able to tell. Well, we'll see how it goes. Hopefully it will be masked. And then I've also rendered it in wireframe here, so you can see what the geometry is like. So it can actually, because it's like a UV sphere, and it can actually be changed, the resolution, so I can change the number of times it wraps around, or the number of times it goes down, sectors and stacks they're called. So you can see I've just changed them using these constants, and then that's very helpful, so I can use that later on to change the detail. And then I've also added a lighting system just quickly, and it's very helpful. The normals are the same as the positions, so I don't actually have to load up an extra VBO for normals, which is brilliant for space because it means that I can just cut out a whole VBO. We've only got positions and texture coordinates. Lovely. These are also all unit spheres, so I've just got one model, and then we can use the transformation matrix to scale it up later. So next I wanted to generate some procedural textures. So you can see here I created a way to load up some pixels to the texture buffer, and I've just created some noise here, but this noise isn't going to cut it for our lovely terrain. So I created a Perlin noise function, which is we can tune the frequencies and octaves of the Perlin noise. If you don't know what Perlin noise is, firstly, what have you been doing? Having a social life? And secondly, I will leave a lovely video about how the algorithm works. It's a very interesting algorithm, but it's brilliant for random generation of terrain, like the planets, or if we go onto the land, the actual landmass itself. However, once I applied this to the sphere, I encountered a problem: stretching. The problem is you can't project a 2D plane onto a 3D sphere without stretching it somehow. If I wanted a perfect image, I would have to create a 3D texture. This would be the same as a 2D texture, but instead of a plane being filled with Perlin noise, a cube would be filled with Perlin noise. However, this would have been very wasteful, as most of the data would never be used, and so it would just be a massive waste of space and performance. Instead, I've opted to create a cube map texture. This is a cube with 6 2D faces, and we can then essentially shrink this onto the sphere. It will still create some stretching, but it will be a lot less noticeable than before. So I created a function that can create cube map Perlin noise and applied it to the sphere. And you can see here there are still some seams, but that's easily fixed. So now we have a beautiful procedurally generated ball of gradient noise. Now, I know some of you are going to be asking, but Matt, why are you making this? It looks nothing like a planet. Well, that's because this isn't going to be the texture that I use on the surface of the model. Instead, I'm going to use it as a map to colour the model in the fragment shader. I'll show you what I mean. I started by using a sort of threshold system for the colours in the fragment shader. Rather than displaying the Perlin noise, I've used that to create sections as shown here. I then just randomly generate a colour and applied it in the different shades to the sections. It's not perfect, I'll probably end up changing a lot of this later, but it'll work for now. To introduce this next bit, let's do a little exercise. I have 2 planets here, one of them is high poly and one of them is low poly. Can you spot which is the low poly? It's this one, obviously, dead easy. What about now? It's a lot harder to tell. Clearly the model doesn't need as high a poly at a greater distance. What I want to do is essentially mapping the resolution of the planet model. I'll create a system which swaps out the model for a higher or lower poly at certain distances to hopefully improve performance. So I've implemented this. I've exaggerated the distances for the levels for demonstration, but you can see up close the sphere has a lot of geometry, but as the camera starts to move further away, the level of detail decreases. More specifically, the number of sectors and stacks halves for every map level. And I've used a logarithmic function to determine the distance between the levels. I've also added a second planet over in the distance to show that this works with multiple planets and they can have different levels of detail. I have a couple of plans for how the planets are going to function and what they're going to be used for in the wider gameplay, but they aren't quite finished yet, and they sort of rely on some other features, so I'm going to save that for a later date. I will leave a link to the sources I've mentioned in this video in the description. If you have any additions or improvements, make sure to put them in the comments. I hope you got what you came for. Cheers.